Problem 5. I need to find out value of this load resistance to get the maximum power from rest of the circuit. Also I need to calculate the maximum power at load. I am following maximum power transfer theorem. First I need to find VTH or open circuit voltage. So removing load resistance and the voltage across this X and Y, that is the open circuit voltage, which is VTH. I need to calculate this one. I need to calculate potential between point X and Y. So this is VOC. To calculate this, I have to find out potential at this point and potential at this point. Now what is potential at this point? Potential at this point is equal to current through this resistance multiplied by this resistance. Now considering potential at this point is Vx. Now this point are same point. So the main current, this one, has been divided into two parts. One part is this one, another part is this one. So this 5 ampere current will be summation of this current and this current. What is this current? This point potential is Vx. So Vx divided by 5, this path current I1, and Vx divided by 2, this path current I2. So see, this is I1, this is I2, and summation of these two is 5. From this I got Vx is equal to 7.143 voltage. This is potential at this point. Now potential at this point Vy. Now this Vy is equal to VAB. Now here the current is flowing through this path. Now when this is the direction of the current, here it will be positive, it will be negative. So Vy will be minus of 4 multiplied by this current. So minus of 4 and this current, value of the current is 2. So Vy is equal to minus 8 volt. Now VOC is equal to Vx minus Vy. VOC is equal to Vx minus Vy. Value of Vx is 7.134 minus value of Vy is minus 8. Ultimately VOC is 15.134 voltage. Now to find RTH, the load is removed. See here, this current source will be opened. This current source is opened. This is the circuit to calculate RTH. Here this 5 and 2 are in parallel with 4 in series. This 1 is not in the circuit. If it is difficult to understand for you, then you can redraw the circuit in a simple way. Say this is point A and this is point B. Start from point A, having two paths. One path is 5, another path is 2. Meeting at a particular point. From this point another resistance is 4. So this is 4, this is 5, this is 2, and ultimate this is the point B. So it is clear that 5 and 2 is in parallel and 4 is in series with that. Ultimately I got 5.43 ohm RTH. So 15.14 is Thevenin voltage, 5.43 is source resistance. To get maximum power at load, the value of load should be same as RTH, that is 5.43. And using the formula I got 10.6 watt is the maximum power at load. Now checking whether I am correct or not. See here, this is Thevenin voltage, this is Thevenin resistance. The load resistance should be equal to Thevenin resistance, that is 5.43, and in main circuit also I have used 5.43. Now if I get power same as 10.6 watt in main circuit at load as well as in equivalent circuit at load, then it can be confirmed that my calculation is perfect. So running the simulation, say the power here it is 10.6 watt, in main circuit also 10.6 watt. So my calculation is perfectly okay.